All right, good people, here we go. The last example, example number 4. We're still factoring. We're still trying to figure out what times what gives me 2x squared plus 5x minus 12. Where do we start? We build the box. 4 squares. What do I put in the first square? The first term. What do I put in the last square? The last term. And then we have to figure out what to put into these 2 squares because we only have one more term left. So we're going to multiply. We're going to multiply this coefficient, 2, times this constant, 12. Well, if you multiply 2 times 12, you get 24. I want to know what times what gives me 24. Again, you could use your calculator. You don't have to. I'm going to go to y equals, and let me erase things that I had left in from the previous example. Our value is 24. We want to figure out what times what gives me 24, so we're going to divide it by x. And then let's go to the table, second graph. Ooh, there's a lot of numbers that give me 24. It could be 1 times 24. It could be 2 times 12, 3 times 8, 4 times 6, 5 times a decimal. I'm not going to use that one. 6 times 4. Oh, that's the same thing as this one, except it's backwards. So I think I can stop looking. So really there's 1, 2, 3, 4 pairs of numbers of whole numbers that multiply to give me 24. So I'm going to write them down. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Awesome. But I'm looking for the pair that when I subtract the numbers, I need to get a positive 5. Positive 5. When I subtract, okay, well, if I subtract 1 and 24, I'm either going to get positive 23 or negative 23, depending on the order that I put them in. If I subtract 2 and 12, I'm going to get either positive 10 or negative 10, depending on which order I subtract. And if I subtract 3 and 8, I'm going to get positive 5 or negative 5. Oh, I think I found my pair. If I subtract 4 and 6, I'm going to get 2. So the difference between the numbers will tell you which one to pick. But now, because it's subtraction is very picky about the order, I need to make sure that I subtract in order to get a positive 5. And the only way to do that is to take positive 8 minus positive 3. 8 minus 3 will give me 5. So then I have positive 8x minus 3x. And that's how I know how to fill those in. Great. Now we're ready to find out what these have in common. Oh, take a look at this. What do these two have in common? They definitely have an x in common, but now they have a number in common as well. Both of these are divisible by 2. Do you see that? I can divide this by 2, I can divide that by 2. So they have that in common. I can divide this by x, and I can divide that by x, so they have an x in common. Great. What times 2x will give me 2x squared? Well, I already have the 2, and I already have 1x. I just need another x, so this is x. And then what times 2x will give me positive 8x? What that would be, if I multiply by positive 4 or plus 4 times 2 will give me 8, and then the x is already there. And then the last one here, what times x would give me negative 3x? Well, I already have the x, so I just need to multiply by negative 3. And if you multiply negative 3 times positive 4, you get negative 12. Congratulations, you just did the factoring. This is the first factor, and then this is the second factor, and you're done. Do you want to check it? You can. You can use your calculator to check it. Remember, you're going to put this original trinomial in y1. You can put the factors that you found in y2, and if you factored correctly, then everything should match. The graphs should be the same graph, and you'll see it in blue, and then you'll see it in red because they match perfectly. I want to do it with you, not because I don't think you can do it on your own, but because I want to show you what would it look like if they didn't match. So let's clear that out. We're going to do 2x squared plus 5x minus 12. Okay, and then in y2, we're going to do 2x minus 3, and then x minus 4. Oh, I put too many x's. Delete. Oh, and it's plus 4. Okay, well, you know what? That could have been our check to see if we did it right. So if I graph them right now, I see this graph and I see the same graph, right? But what if I had left this as x minus 4. Then when I graph it, I'm going to see this graph. Oh, they're not the same. So do you see how if you don't have the right factoring, you're going to see two completely different graphs. But if you have the correct factoring, if you did the process correctly and you have the right answer, then you're going to see the same graph. This is one of the reasons why some students like to check it to make sure that their answer is correct. So your job is going to practice this. I'm going to leave you with 7 examples for you to practice with. I'm going to leave you some space to do your box method. The other thing I'm going to give you is this factor bank. And what that means is all of the factors and all of the answers have to be on this list, and they only get used once. So you can check to see, like when you do number 1 and you have the 2 factors, are your 2 factors in this bank? And if they are, well, then you can scratch them out or whatever. I don't know if those 2 are the ones, but you can scratch them out. And then when you do number 2 and you get your 2 factors, are they in this? Oh yeah, you can scratch them out. Maybe it's those 2. I don't know. But the idea here is that you can at least check, is the answer that I got one of the possible factors? You're not going to use them all. You're not going to scratch them all out. There's going to be extras. But at least you know that the answers for the factoring have to be in this little box. So you can kind of check yourself there. And that's the day 1. It's really a review of what we did right before we went to Thanksgiving.